Let us now do a simulation for the full bridge converter circuit. I have within the resources folder a folder on full bridge, and within that you have the full bridge schematic, netlist, CIR file and the subcircuit model files. So when you open the fullbridge.schematic, it looks something like this. You have a full bridge circuit diagram here as we have discussed. Switch Q1, Q2, Q3, Q4, and they are driven by gate drive signals G1, G2, G3, G4. So these two are mutually exclusive, these two are mutually exclusive, these two are switched together, and G2 and G3 are switched together. So you can observe the waveforms at A and B and across AB. So I have here, like in the half bridge and the push-pull, a current sensor, a 0 voltage element put as a current sensor. On the secondary side of the bridge, center tap bridge, you have 0 voltage current sensors to sense the ID1 and ID2. The center tap is the reference node point, and from the pole you have the inductance and then the output with the C filter and R0. So this is your full bridge circuit. You see that I have 10 turns on the primary, 20 turns on the secondary, turns ratio 2. So you will get V pole, here it is 10, so you will have 10 volts at the primary, 20 volts for P, but you will have the diode drops and the on-state drops of the switches. There are two on-state drops, so you will have one on-state drop for switch 1, another on-state drop for switch the other switch S4, which will come into the picture. Then you have the diode drop, so you probably will land up with around 3 to 3.5 volts drop overall, so you may have some 16 volts at pole voltage. Then the duty cycle and output voltage comes in here. And if you go down here, I am using the same PWM bridge. The first arm top switch drive, this is G1. First arm bottom bridge drive, which is G2. Second arm top switch drive, G3 and G4. And always remember that G1 and G4 are switch 1 and switch 4 are switched on simultaneously cross, and switch 2 and switch 3 are switched on simultaneously and in a mutually exclusive manner. Now let us simulate this circuit and then see. We'll go to the terminal and run the simulation in ngSpice. So I am in the terminal. I am in the folder full bridge. So let me run the netlist. Let us generate the netlist from the schematic. So you have the netlist generated. Now run ngSpice from the CIR file. I have used a similar CIR file like I used for off bridge and push-pull circuit. So on running, you get the waveforms like this. As before, I have measured the current through the inductance, output inductance, current through the diode D1 and current through the primary. So if I zoom in and look at that, you will see it a bit more clearly. The red wave shape is the current through the inductance going up and down at twice the frequency as the switching frequency. The blue wave shape is the current through the diode. See that it follows the inductor, and then during the freewheeling time it takes only half the current and the remaining half current flows to the other diode. And the orange waveform here is the primary current waveform, which is reflected onto the primary of the full bridge circuit. Let me plot VAB. VAB is the voltage across the bridge. So this will give you the voltage across the primary, and let us see how it looks like. So if you plot that voltage, and let me take a small portion of that, if you see that the voltage, when one set of switches are on, you will see the primary dot end positive, and it is VDC minus the saturation drops of two switches. And then when the non-dot end is positive, you have again on the other side the primary voltage. These two should balance each other, and during the time when all four switches are off, you see, observe that there is no induced voltage across the coil. The primary voltages are 0. So this is typically the type of operation that we expected, and I will leave it to you to explore this full bridge circuit, change the values, and try to learn as much as you can from this simulation.